Hello and welcome to Euphoria. This channel explores designing, creating and building models for a LEGO city. We'll be exploring the joys and challenges of building official LEGO sets and designing and making modifications and my own creations. In this series of videos, I'll be explaining how to develop the concept, design and build for a LEGO creation of my own design, a MOC. I'm going to be creating a building for my LEGO city. It will be an old astronomical clock that sits in the centre of the town and is a historical landmark and tourist attraction. In previous videos, we looked at the inspiration behind this MOC, the concept development, and the selection of options leading to an outline design. In this video, which is part 4 of the series, we will take the outline design, which we developed in part 3, and take it further into the design phase. So, in this first phase of the design, I'm going to develop the structural design for the MOC. This video will be followed by further videos covering the rest of the design and then the build of the MOC. Look out for those coming up. So here's a reminder of the outline design for this MOC that I developed in the previous videos in this series. It's going to be based on the Harry Potter clock tower facing the front, with the clock and the entrance also at the front. It's going to be a corner modular building, which means it needs to connect to a modular building at the side here and another one somehow at the back here. The building will keep the cross-gable roofline of the original clock tower. It will have a tower on the left-hand side, probably towards the front, based on the octagonal towers from the Whomping Willow set. There will be a fountain outside the building, also on the left-hand side. There needs to be access round the left-hand side of the building, which would be a passageway between buildings, or, if repositioned, could face onto a road. Looking at the clock tower build, I think it will split fairly easily into 3 levels. But if I'm going to use the parts that I like from the Whomping Willow castle, I need to work out how to make them into separable floors in modular style. This is the first in this series that looks at the design phase. There are different stages of design, and I'm going to start here with the first one. This looks at the structural design, which will cover the design of the walls, floor and roof that form the main structure of the building. Based on the outline design, we will develop the basic shape of the MOC, work out the size of the MOC, that is, its overall dimensions, work out whether the build is made out of separate sections that can be constructed separately. For a modular MOC, this will at least be the separate floors of the building. Those should let me develop the rough floor plans for the different stories or levels. I'll also need to consider how the design provides support for the floors and the roof, whether it has enough strength, and how it will conform to the modular building standards. All of those factors go into producing the structural design. That's why I call this the S phase of the design process. I'll be developing this design in a combination of computer-aided design using LEGO Digital Designer, or LDD, and there will be an element of prototyping using real bricks. This will run alongside the design phases so that I can check how some of the elements fit together physically, to test the strength of some assemblies, and to see how things look. For this particular MOC, I'm fortunate that I already have a lot of the parts I require. That's because I bought and built the Harry Potter Hogwarts clock tower set and the Harry Potter Whomping Willow castle. The construction of those sets has given me familiarity with the parts and how I might want to use them. It's also provided me with a large number of parts that I can use for prototyping some sections of my new MOC. If you want to see how I built those and the ideas I got from the builds, please see my other videos on my channel. There are links in the description below. If you don't want to use a computer, you could do the structural design using pencil and paper. After all, that's what architects did for centuries. Using squared paper makes it a lot easier. So in this video, I need to cover high-level design decisions such as floor plan for the building, wall heights and outlines leading to what would be called in architectural terms the elevations of the building on the different sides, locations of doorways and entrances, wall thicknesses and openings or gaps in the walls, how the floors and roof will be supported, the design of the roof, that's the shape and how it will be constructed, and for this mock, the design of the tower, that's its size and shape and how to make it, the location of the main features like the arch at the front and the clock and the fountain at the side, and how it will meet the modular standards like the positioning of modular connection points, blank or connecting walls, and the pavement, etc. So now let's make a start on the structural design for this mock. First, I'm going to look at the size and shape of the building. That should give me the footprint of the building and the position of the main features, and that will let me develop the floor plans. We saw in the outline design that I want this mock to be a corner modular building. One of the main factors in this design is that I want it to meet the standards and conventions for modular buildings. Without those constraints, I could make this building any size or shape that I wanted. But I have to make the building so that other buildings could go on the back and on the side. That means that the building has to incorporate the connection points for modular buildings at the back and side as shown here. I want to reuse some of the ideas and features of the Harry Potter clock tower set. That set has no back and is only 6 studs deep at the base. I could make a full building by copying the same structure to make the back half of the building, but it would still only be 12 studs deep at the base. That doesn't quite work for the position of the modular connection points. So I may need to adjust the building size or add something to make the wall deeper. Also, if I look at the footprint of a building that is back to back, it doesn't fit in the right place at the back to fit with the modular building standards. Really, I need to shift the centre line of the roof so that it lines up with the modular connectors at the back here. That might be possible, but it gives me an L-shaped building and the front gable would be moved quite a long way over, so it doesn't really give me much room for adding a tower on the side. I did try to get around this by adjusting the footprint of the building so it had a kind of staggered roof, but that also gave me problems with the tower. To solve this problem, I decided to keep the cross shape of the roofline, but move the centre line of the building over part of the way. Then I can extend the building at the back so that it reaches the back of the base plate and connects with one of the modular connection points. I'll join on to the other one by extending the building somehow on that side. So the footprint of the building would look something like this. Now I'm going to work out how to design the tower so that it fits on the side of the building, somewhere on the front corner. In the previous video, we saw how a tower using these octagonal plates doesn't work for a number of reasons. They're rather large for the space I have available, as they're 10 studs across, and it's difficult to make angled corners that fit on here properly. And it's quite difficult to make a roof that fits on here as well. They're too big for the conical roof pieces to fit on neatly, so the tower will need to be a bit smaller than that. I did consider how to make the roof for the tower, assuming that it's not just a flat roof. I could just make it out of slope bricks, but that's quite difficult for an octagonal tower. So I did a survey of roof pieces that I might be able to use for a tower. This big roof is such a great shape for the roof of an old building. Unfortunately, it's not a current part, so it's only available used, and it's too big for what I have in mind, as it's 12 studs by 8 studs, and it would overwhelm the rest of the build. There is a cone that's 10 studs across, but again it's too big for what I need. There is a really neat tower roof available that's 8 studs by 6 studs. It's a great shape and would make an interesting tower roof for my MOC. Unfortunately, it's not a current part, so it's only available used, and it's only available in bright red. Now these cone parts actually come with the Harry Potter sets. You get 1/2 cone in the clock tower set and one in the Whomping Willow Castle. So together they make a conical roof of 8 by 8 studs. It fits well on an 8 by 8 octagonal tower and is the same dark grey colour as the rest of the roof, so it's the best candidate for the roof of the tower. There's also this interesting dome that's 7 studs by 7 studs, but that seems quite hard to use and doesn't fit with the style of the building. I could make a smaller tower that's only 6 studs across, but I think that's going to be a bit small, and if I'm using these corner pieces, it doesn't allow room for any windows in the tower. So all of that results in a design for a tower that's going to be 8 studs wide and incorporates the use of these corner panels like this, so that the conical roof can sit on top. It also provides room for a small window in the sides of the tower. Now I need to look at how to position the tower to attach it to the building. I could make a half tower that would go on the side of the building like this, or I could make a 3-sided tower like this that would go on the corner of the building. It could fit structurally, but I need to think about how the tower roof would fit into the rest of the roof line. It actually turns out to be quite difficult to connect an octagonal tower with a conical roof onto a building with a cross-gable roof running 2 different slopes. After some experimentation, I settled on an arrangement where the tower forms one corner of the building. The conical roof will sit on the top of the tower, so that the gable roof of the clock tower only has to fit around the octagonal tower on the corner of the building. Depending on the final design and the height of the tower, I'll probably need to get some more of the corner pieces used for the tower. But as they are current parts, there's plenty of availability should I need to obtain more. If I were doing the design on paper, it would look a bit like this. So now the footprint of my building looks a bit like this. I've realised when designing MOCs that the roof is actually one of the first things you need to design. That doesn't sound intuitive. Surely the roof is just there to cover the walls, right? But actually it's the other way round. The walls are there to support the roof, and the way that they support the roof will depend on the design of the roof. If it's just a plain flat roof, perhaps made out of concrete, such as you might find in a modernist build, then the shape isn't so critical, although it will still have to be supported. But in a more traditional roof, the walls need to support the edges of the roof and may need to support them at other points as well. Even when building in Lego, you have to think about whether the roof will be strong enough, and if you're going to make the roof so that it can be removed, so that you can get inside the building, then you have to think about how the roof section itself will be built and whether it will be strong enough. So actually you might need to design the roof quite early on, because the walls will have to be in the right places to support the roof. Now, I really like the roofline of the Harry Potter Hogwarts clock tower. It reminds me of old buildings that I've seen in historical centres in continental Europe. This design gives an interesting cross-gable roof. This is quite hard to achieve, especially with two different slopes, and the Lego designers have done some heavy lifting here on the design of this roof. So I intend to reuse the design for the roofline. I'll start by mirroring the building. That means that the front slope, that's 7 studs deep, will be mirrored at the back of the building, making it 14 studs deep. But I really like this feature where the top floor and roof section is wider than the supporting walls. That actually makes the supporting wall structure 12 studs deep. This confused me for a while because the footprint of the roof, which is already quite complicated, isn't quite the same as the footprint of the supporting walls. So when I place the copied roof structure onto the wall structure, I can see what I need to do to make them fit together. What I will do with this roof line is extend it sideways to fit properly onto the increased width of the building. I'll need to work out the construction details, but the structure should work okay. And I'll need to extend the back part so that it fits onto the increased depth of the building. But you can see that if I keep the overhang of this part of the roof, then I've got the walls in the wrong place. So I need to adjust the walls to fit. And then finally I need to adjust the bit of the roof where the tower will be so that it fits without having lots of gaps or sections of flat roof. After playing around, I came up with a design where the final positioning of the tower meant that all I have to do is make the roof on this side meet up with the wall of the tower so there are no gaps. Then the conical roof for the tower becomes independent of the roof for the main building, while still reflecting the angles of the main roof and the smaller cones on the gables. So that's more or less worked out the basic structure of the roof and how it will integrate with the structure of the walls and the tower. Now, I think the roof and the internal floors may need some additional support. The beam forming the ridgeline of the roof is supported by the gables, but it's quite long and will need some support along its length, especially as it's supporting the ridge of the cross roof. I can use arches, columns or cross beams for that. Where I use a column or an arch, then it needs to be supported by something underneath to take the weight down to the ground. I didn't want one column right in the middle of the building, so I placed a column here, which will support the upper part of the tower, and a column here, which will help support the gable roof at the other side. I'm also going to add beams and arches across the internal voids in the walls so that there's some strengthening of the structure across the building. That will tie the walls together, avoid outward pressure on the walls, and keep the whole building solid. That support structure will also determine where we can have openings in the walls, including doors and windows. Now I'm going to look at the overall size and structure of the floors. The detail of construction will come in the next stage of the design. Each floor needs to support the walls and the other elements of that level of the building, and it needs to be supported by the level below it. And of course the floors need to meet the walls and not have any gaps. If the building were to be built in sections, then the floors also need to separate at the right places. If the building has any changes in level, then the floors need to change levels at the right places. I'm not expecting that for this MOC, so each floor can be made as one piece. In modular buildings, the floor is also the point of separation for the different stories, so that each story can be removed separately. The way that's done is using a layer of tiles with no studs or just a few locating studs, so that the floors can be removed easily. So I've prototyped the shape of the first floor using plates that I have available. It's a bit of a strange shape. The difficult part is on the corner where I have to make the shape of the tower. There isn't a plate that's the exact octagonal shape of the tower. So the floor has to be made of several smaller plates, and we need a way of joining them together that's strong enough and doesn't leave too many unsightly gaps around the edges. There is a limited choice of parts that matches the angles of the tower, but I can use these wedge-shaped plates and these half-circle and quarter-circle plates to support them. The second floor will be built similarly, and the tower floor can be built in the same way. But due to the overhang over the first floor, the second floor will be slightly bigger than the first floor. So now we have the floor plans for the ground, first and second floors. In the next video I will develop the design for the staircases and therefore the holes that I need in the floors to accommodate them. Now I'm going to work out the wall sizes or heights so that I can develop the elevations for the build. This building is going to be minifig scale, so each story needs to be at least 6 bricks high and probably between 7 and 9 bricks high. The normal height of a 2-story modular building is 25 to 26 bricks. That's usually 8 or 9 bricks per story, plus the floors, which usually take up 3 plates or 1 brick each, plus the roof, which often contains an attic room, so it might be 7 to 8 bricks high as well. For this build there will be 2 stories at say 8 bricks each, and 2 floor layers at 1 brick each, plus whatever I need for the roof level. The Harry Potter clock tower roof is 8 bricks high at the sides and 12 bricks high at the front. If I use that as it is, then I get a building that's 26 bricks high at the side, with the front gable rising to 30 bricks, plus the finials on the roof which add to the height. I'll need to work out the height of the tower to match, plus it will have its own conical roof on top. So I think I'll have a reasonably imposing tower-like structure, at least for what is meant to be a very old building. So far, I've just looked at the structural parameters for the building without considering how the building will be used. I will look at the internal structure of the building, including rooms and their uses, at the next stage of the design. Up to now, I've just put in blank walls as placeholders. To complete the elevations of the building, that is, to complete the design for its structure, I need to decide where the doors and windows will go and the location of the main external features. I want to put a back door at the rear of the building. It has to go in one of these corner walls, so I'll put one in here for now. I'm going to put windows into this building, suitable for an old building made of traditional materials. So I'm going to use small windows like these that fit within the theme. In the tower, I'm going to use these arched windows that fit in the narrow space available between the walls. And in the rest of the building, I'll use a combination of small arched windows and the small square windows. In the upper floor, I might try one or two of these larger windows to give more light in the building. Sometimes the windows don't look right, so I may adjust their sizes, styles or positions, and anyway, the final positions will depend on what I do with the internal layout. The astronomical clock will go on the front of the building. I expect it to fit on the first floor in place of these windows. I'm not sure what it will look like. I may be able to keep this arch depending on how I build the clock. I expect to keep the main clock at the top of the building using the parts from the Harry Potter clock tower set. I'll decide on how to do all that in the next stage of the design. I still want to keep the fountain in the design. Now that we've settled most other things, there's only one place that the fountain can go. That's in the side wall of the building round here. The fountain and its surround are 8 studs wide, so there's just about enough room to fit it in this wall. The exact details of the fountain can be decided in the next stage of the design. We just need to finish off the structural design by ensuring that it meets the standards for modular buildings. That means it has to incorporate the modular connection points at the side and at the back. As you can see, the building isn't quite deep enough at 12 studs to completely include the 2 Technic bricks that form the connection points at the side. That can be dealt with fairly easily by adding a small amount of buttressing at the front and the back. And at the back of the building, that does incorporate one of the Technic bricks, but not the other one. However, we can include this easily by building the fountain in the right place so that it includes the Technic brick at the back. We've already dealt with the floors being separable. The other modular standard to be dealt with is the pavement layout, which I'll cover in a later video. One of the things we need to address at this stage is cost or budget for the build. This could perhaps have been considered during the development of the concept, but at that stage we didn't really know enough, although my expectations then were that it would cost about the same as an official LEGO modular building, or perhaps a bit more. Modular buildings are quite good value when you look at overall cost per piece, so the cost will depend on whether I use fairly common parts that aren't too expensive. However, I can set some parameters around cost. A typical LEGO modular building has about 2,500 pieces, including minifigures and accessories. I would expect this MOC to be about the same, or perhaps a little more, as it's a bit larger, and I may want to tile the internal floors, which can use up a lot of parts. I spent £75 on the clock tower and £31 on the Whomping Willow. With the cost of a base plate and the additional pieces, it may well cost more than a new modular. I'll look at costs again at a later stage. So now we've got a structural design for this MOC. It's looking like a building that could be constructed out of Lego, and we have a clear idea of what it will look like. We've developed the basic shape of the MOC. We've worked out its size, that is its overall dimensions. We've worked out the separate sections that will be constructed, which will be the 3 stories of the building, and we have the rough floor plans for each level. We've also considered how the design provides support for the floors and the roof, whether it has enough strength, and how it will conform to the modular building standards. I also touched on the likely cost of the MOC, but I'll work on that a bit more later on. So that was a look at how I developed the structural design for this MOC. There are still quite a few things to decide as we develop the detailed design, like exactly how to build the roof, how to fit in stairs between the levels, details of the doors and windows, details of the fountain feature, how to make the astronomical clock feature, the exact construction details and colours of bricks to be used, and trying to use as many as I can of the bricks that I already have. I need to work out what to put inside, and last but not least, what other bricks I need to complete the build. Look out for the next video in this series, in which I will look at the next stage of the design for this MOC. Thanks for watching. Please let me know what you think in the comments below, and subscribe to this channel if you want to see more videos about LEGO modular buildings.